Good morning, geometry class. We are going to do a quick review of test 13A. That is the test we took a long time ago, and I know we sort of forget what we did, and I sort of forget what all we got wrong and all that, which is my fault, and it's pathetic on my end, not on yours. But we're just going to do a quick little review and hopefully clear up any remaining questions. If you do have questions yet at the end of this video, then text them back to me and say, I still don't understand question so-and-so, and we can maybe clarify. Get your tests, please, and have them in front of you. It's test 13A. Looks like this. You should have them from a couple days ago. Looks like this, and I know you've had time to look at them, but we want to just put them in front of us and kind of go through to clear up any questions, because I didn't necessarily write all the answers down on your paper, at least not all the work, how you get it. All right, and like I said, I don't remember which all ones we got wrong, but I'm going to try to pick and choose here and hopefully get most of them. Number one, a searchlight rotates 60 degrees through a circle that has a radius of 120. What is the area the searchlight covers? That area is 7,540 square feet. The way you get it is area of a circle and then a sector of that. So the circle is here, the radius is 120, and we're talking about 60 degrees of that. So 60 degrees, we want to know what is this area that the searchlight covers. And so it is pi times radius squared, and then 60 over 360. So you should be able to do all that and come up with 7,540. Number two is pretty simple. I don't think we need to go that one. 15.6, because it's 46.8 divided by 3. Number three, problem number three, there was a few people here who got it wrong. This is two figures, and they're in ratios of 4 to 5. So anything that's 4 over here is 5 over here on this side, and the 4 side is 38. The perimeter is 38. So the quickest way to do that is 38 divided by 4 times 5, and you get 47.5, which is the right answer for number 3. Number 4, it is a mid-segment. ST is a mid-segment, so that means that S is in the middle of W and X. You should be able, that should tell you that A equals 3. And B, since it's going from, the point is X here, and it's going this way, and ST is 5, and it's halfway here. It's going from 0 to this one, and 5 is in the middle. That tells me that that is 10. So B equals 10. Number 5 is half of 230. That 230 might be a little bit unclear, but it is arc AB. The whole way around is 230 degrees. I don't know if I clarified that or not. But anyway, 230 divided by 2, you get 115 degrees for that measure. Number 6 is a proof. They sort of snuck it in there, and I think I was pretty lenient on this one, but the technical way is you have to prove that DHF is 90 degrees. If you can prove that, then you can use theorem 58.2, I think, or something. We understand that if we have a line that is perpendicular to a radius, like if we just use this one, and we can prove that this is perpendicular, then that proves that it's tangent. So, and there's a triangle in there that is a 45, 45, 90 triangle. That triangle is EFH. Well, if EHF is 45 degrees, then, well, let's see here. Yeah, so okay, here we go. DHE is 45 degrees. It tells us that. And then we prove, because that's an isosceles triangle, we say that EHF is 45 degrees. Well, the arc addition postulate says that one angle plus another angle equals the whole thing. So DHF plus EHF equals DHF. I'm sorry, DHE plus EHF equals DHF. Now, you need to look at that drawing for that to make sense. But since you have that, then you've got 90 degrees, and that proves it is tangent. Anyway, I was, like I said, fairly lenient on that one, I think. All right, number 7, quadrilateral ABCD. They give you some information and ask, is ABCD a parallelogram? The answer is yes, it is. And there's a proof in there. You can do it, and that has the two triangles and reflexive property. AC is congruent to itself, and then you have some other angles, and then they're parallel, so you have alternate interior angles. You prove the two triangles are congruent to each other, and then that'll tell you that the sides are, and then you can say it's a parallelogram. However, it's not asking for a proof, so simply yes, it is. a parallelogram is a good answer. Number 8 is 84. That is simply 3 times 7 times 4. Base times the area of the base, so it's the width times the length of the base times the height. 3 times 7 times 4 is 84. Number 9, area of the parallelogram, pretty simple. 6 times 9 is 54 square feet. The names, the labels, number 8 should be 84 cubic feet because it's volume. It should be 84.3, and I don't think I counted it wrong for some of those. Number 9 should be 54 square feet since it is area. Number 10, if x equals 7, then 35 minus 8 is not 28. It's 27, so it is not a rhombus. A rhombus has all 4 congruent sides. So if x equals 7, that is not a rhombus. All right, turn the page. Number 11. This one, there was maybe some questions still on this one. And it can be done without a calculator. So there was somebody that said, their calculator doesn't do square roots and so on, or they don't have a scientific calculator at home. That's fine, but you could still do it this way. Here is a triangle, and it has side lengths of 14 inches. And what is the area of that triangle? I think that's what it's asking. Yes, so we need to know, first of all, area of a triangle, area is 1/2 base times height. We need to know that, we need to recall that, and we know our base is 14. We have no idea what our height is, so we need to find this line right here. If you bring that triangle out right here, you can get 7 and 14. Now, you could use the Pythagorean theorem, a squared plus b squared equals c squared, and come up with some answer for this, but it would probably not be in the square root form. The other way is to use the 30, 60, 90 triangle. Remember our sample 30, 60, 90 triangle. If this is 1, then this is 2, and this is the square root of 3. So this is the proportions. These sides will always be in this proportion. Well, here's a 7, here's a 14, so that's our 1 and our 2. And then to go from here to here, you go 1 times the square root of 3. So whatever this is, times the square root of 3. So this length is 7 square root of 3. That's the height. Now you go back up to this triangle. Since we're not necessarily wanting to know the area of this, we want to know the area of the whole thing. We can say that this is 7 square root 3 for this length here, and then put it in this formula. So our new formula, if I come over here, area is 1/2 of base. Base is this, 14 times 7 square root 3. Not too bad. 1/2 of 14 times 7 to the square root of 3. To get rid of this 1/2, you could simply simplify this. 1/2 times 14 is 7. So the area equals 7 times 7 square root 3, and multiply that together, and you get 49 square root 3, and that's the answer in simplified radical form. And I did not use a calculator for that. It's pretty simple. 14 times 1/2 is 7, and 7 times 7 is 49. So 49 square root 3. You find the square root 3 from right here. He appears in this proportion, and then he just goes along for the ride, and he rides down through here and goes out in the end, and you do 14, half of 14, and then you take 7 times 7. So 49 square root 3 is the answer. Number 12. 12, I don't know if I clarified that one or not. Some of you got close, I think, but the correct answer is a line y equals 4x minus 10. And there are a couple ways you can do it. One is you can graph it up here. Just graph the points and see. And I'm not going to do that because I have something else up there. The other one is to use 3 and 2 and come up with a new. This is probably the more proper way, and I'll do this quick. Remember, the equation of a line is y equals mx plus b. Y equals mx plus b. This is sort of a generic, it's kind of describing a linear equation. And the things to note is this is the slope, the m value is the slope, the b value is where it is across the y line. Now we just need to fill that in with our new information. First of all, a line that's perpendicular to this line that's given. The line that's given is y equals negative 1, y equals negative 1, 4x. And that's it. So the slope is right here of the old line. We want a new line that's perpendicular to this line. So negative 1, 4. What is the opposite reciprocal of that? It's 4. So we right away know that y is going to equal 4x something. We don't know what. But we can plus b. Now we can add our 2 and our 3 in here. Our 3 and our 2. It's 3 and 2, that's the points that it's going through. So if you put 2 over here, 2 equals 4 times 3. What I'm doing is taking the x and the y from here. This is the x value, it's 3, and the y value is 2. This is our new line that we're concerned about to go through these dots. You can take this and plug it into here, and now we have known values for this, this, and this, and then we can solve for a b and put that back up into here. So 2 equals 4x plus b. Well, 2 equals 12 plus b, and take this over, and b equals negative 10. Wanted to make sure I was doing that right. So 2 equals 12 plus b, which means, bring this over, and you get negative 10 equals b. So go back up to this one, and now it's plus b, but since b is negative 10, it becomes negative 10, and this is the correct answer. That's the answer for 12. Again, you could do it over here. You'd find the points 3 and 2, and you draw the other line, and you go perpendicular, kind of, and then you see where it crosses the y line, and it would be up here or down here, negative 10. You could graph it, but the better way is to do this, because this way, if it's not exact, like if it doesn't exactly come out on a whole number, you could find it in this math, and you'd know exactly that b equals whatever, 2.3 or whatever it would be. No pun intended, whatever it would be. All right, number 13 is pretty simple because it says find the area in terms of pi. It's asking for a lateral area. Lateral area is just that label, like let's just pretend that's a can and you're unwrapping the label. The label is just around this part. I don't have a cylinder here. But the length is, the height is 5 and the length is whatever the circumference of that cylinder is. Well, what is the formula for the area of the circumference? It is pi times diameter. Well, they give you radius. Radius is 2, the diameter is 4, and pi is going to go along for the ride the whole way down because it says in terms of pi. So the circumference is 4 pi. So this length is 4 times pi. Now you look at that and say, what's this times this for the area? 5 times 4 pi is 20 pi. Again, no calculators needed, it's simple math. Sometimes we think it's difficult because we have these variables and we need to do it in terms of something, but if it's like in simplified radical form, that's kind of like give it in terms of simplified form, and so whatever that square root 3 that we did earlier, I call it, he goes along for the ride just like this in terms of pi times diameter, so 4 pi, or pi times 4, whichever, pi times 4 or 4 times pi, you don't care. You can do the math on the numbers and leave the symbols and the unknowns to go along for the ride. This is the answer for 13. 14, pretty self-explanatory. The small triangle and the big triangle, and the numbers that are known are 4 on the little triangle equals 12 on the big triangle. 4 on the little triangle, 12 on the big triangle. That means the big triangle is 3 times bigger. So anything on the little triangle, you take it times 3 for the big one. A is 6 and B is 15. All right, and number 15, problem number 15. Vertices minus edges plus faces equals 2. 20 minus 30 plus f equals 2. That means negative 10 plus f equals 2. That means f equals 12. Now you can draw that out and actually solve it yourself. But v minus e plus f equals 2. And fill it in, you get 12 faces is the correct answer for 15. 16, it is not parallel because 7 over 3 is not equal to 9 over 4. And you can do the math. 7 over 3 is not equal to 9 over 4 because this is 27 and this is 28. So no, they're not proportional. 7 over 3 is not the same ratio as 9 over 4. Therefore, they are not parallel. 17. Going to move this graph here. I drew the points, but I did not label them. This is point A. This is point B, right here. I don't know if you can see them. This is point C, negative 2, negative 1, point C, and D. All right, it's asking for the perimeter. Again, it says give your answer in simplified radical form, and it might scare you because, well, I don't have a scientific calculator. You don't actually need one. I'm going to draw this for clarification. This is the triangle, the rectangle. This is the rectangle, and we want to know what that total length is to go all the way around there. And you use a distance formula. To me, the distance formula simplifies to Pythagorean theorem. So what is this length right here? This length is the hypotenuse of a triangle that has a leg length of 1 and a leg length of 2. 1 and 2. I'm going to enlarge it here. 1 and 2. And then what is this length? Well, a squared plus b squared equals c squared. So 1 squared plus 2 squared equals the hypotenuse. 1 plus 4. It's a square root of that. It's c squared. So 1 plus 4 equals c squared. So c, I do this, c equals the square root of 5. Now I did that quick, but it's a squared plus b squared equals c squared. Well, I want to know what c is by itself, and to get rid of the square, you have to do the square root over here. I hope that makes sense. You end up with the square root of 5 for this length. Of course, this is a rectangle, so this is the square root of 5 too, because it's 1 here and 2 here. So 1 squared plus 2 squared. Again, the same problem. You get this. So let's just start labeling or let's just accumulate our side lengths up here. We have a square root of 5. We have another square root of 5. And now what do we have? Do the same thing as we did, just count up. We've got a triangle here with a side length of 2, 1, 2, and a side length of 1, 2, 3, 4. So now it's 2 squared plus 4 squared equals c squared. And that is 4 plus 16. So c equals the square root of 20. Now the square root of 20 is not simplified radical form because there is a square in there that we can get out. 20 is the same as 4 times 5. So this equals the square root of 20. These two are the same. And since we have a 4 by himself now, he can get out of there. He can come out, and the way he gets out is the square root of 4 is 2. So you have 2 times the square root of 5. 2 square root of 5 is the length of this. 2 square root of 5, and you have another 2 square root of 5 down here. 2 square root of 5. Now look at this. How many square roots of 5 do we have? 1, 2, we have 2 here, we have 2 here, that's 4, 5, 6. So the total answer is, the total perimeter is 6 times the square root of 5. That's simplified radical form. 6 square root of 5 is the perimeter. No calculator needed. All right, 18, you simply use the Pythagorean theorem to see and know it is not equal. 4 squared plus 9 squared does not equal 10 squared, so it is not a right triangle. 19, it says draw a valid conclusion and then identify which law is used. A lot of you drew a valid conclusion. Some of you did not identify which law was used. I think I wrote them in there. Law of syllogism is used, and the correct conclusion is, if Betty takes a vacation, she goes swimming. Some of you, I think, didn't have the if. It was not a conditional statement. But the two facts that are given is if she does this, then she does this, and if she does this, she does this. Therefore, if she does this first one, she does the last one. So it's still going to be in the if-then format. If Betty takes a vacation, she goes swimming. 20 is seems simple, but it did trip us up a little bit, at least some of us. The vectors are named with the little italicized, lowercase italicized letter. So it's vector P, it's vector Q, it's vector N, and it's vector M. And some of them have terminal points listed, some of them do not. If they do not have terminal points listed, don't make any up. They just don't have any. So you should have a list of P, Q, N, and M, and P has a terminal point of B. It starts at A and goes in the direction of the arrow, and it ends at point B. So the terminal point of P is the terminal of vector P is point B. The terminal point of vector M is point D, and N and Q do not have terminal points listed. All right, that's the test. Hopefully that clears some things up. If you still have questions, does not make sense, please let it be known, and I'll try to clarify that for you. All right, so another test is done. Take these tests now and return them to Mr. Troy, and they get put in the file, whatever he does with them. So don't make copies of them and don't pass them out to your younger siblings to hold for next year. I didn't say that. I didn't give you that idea. Please don't. That would be classified as 100% cheating. So take the tests and give them back to Mr. Troy, and we will then prepare for the next test.